welcome back to another level 1 tables, equations and graphs video. This is still talking parabolic functions, and we're going to talk about the scale change. Okay, we know quadratics are expressions that have the highest power of x squared, and they produce graphs called parabolas. In the last video, we chatted about this idea of adding a number c or subtracting c to the end of x squared, and that does a vertical shift, moves the graph up or down. And we also talked about putting a number inside brackets, and that represents a horizontal shift. Just remember, if it's plus 3 in brackets, we're moving to the left 3 squares. So do the opposite for your brackets. Right, now we're going to chat about a number that's out the front of the x squared. It's called a, and we're going to talk about it as a scale change. So here's our first example, y equal to x squared. Here's what the graph looks like. Just keep in mind that when I write x squared, I really mean 1 times x squared. I don't need to put the 1 there because 1 times anything is itself. So 1 times x squared is just x squared. Now there's a little pattern that some students try and remember. It only happens for the 1x squared. You go from the origin, you go out 1 and up 1. You go out 1 and up 3. You go out 1 and up 5. Then you'd go out 1 and up 7, out 1 and up 9, out 1 and up 11, the odd numbers. So that's a little pattern that helps students remember how to draw the basic parabola. All right, let's talk about the next graph, y equal to 2x squared. Well, here's what it looks like in blue. Let me take away the first graph for a second just to see what's going on. And let me show you what's happened with the pattern now. Normally we go out 1 and up 1, out 1 and up 3, out 1 and up 5. This has changed now because everything's doubled. We're still going out 1, but we're going up 2 instead of going out 1. We're still going out 1, but instead of going up 3, we're going up 6. So instead of going up 1, 3, 5, the odd numbers, we're now doubling everything to 2, 6, 10, and so on. So this is what we call a scale change. The graph, as I call it, the graph's got steeper, narrower. Right, let me put the y equal to x squared back just so you can see the two graphs side by side. The one in red is the basic x squared and the one in blue is 2x squared. So that 2 means the scale's changed, everything's got twice as narrow. Right, what would happen if we said y equal to 4x squared? Well, this graph would be even narrower still. And what about 0.5x squared? Y equal to 0.5x squared. Well, 0.5 is less than 1, so we're going back the other way, and the graph gets a little bit wider, I call it. So I like to refer to it as a narrow graph and a wider graph. Oh, what about this example? Y equal to negative x squared. Well, we did this before. First of all, know that it's negative 1x squared. There's a 1 there that we didn't write. What about negative 2x squared, negative 4x squared, negative 0.5x squared? Well, the same idea applies, but the graph's just upside down. So the graph can get narrower or wider, but because of that negative out the front, the graph's just now flipped over and upside down. Okay, here's example 3. Y equal to 0.25x squared. So the number a out the front of x squared doesn't have to be a whole number. It can be any number you like. Well, here's what the graph looks like. It's quite a wide graph. If you think about the 0.5 was getting a bit wider, well, 0.25 is even smaller and the graph's getting even wider. What would happen if I said y equal to 0.25x squared plus 3? Well, that would be the same graph as y equal to 0.25x squared, but it's just moved up 3. Remember the idea of adding a number at the end moves the graph up. What about this? Y equal to 0.25, that's the number a up the front, bracket x minus 5 all squared. Well, that's going to be the same graph as y equal to 0.25x squared, but because of the brackets x minus 5, the graph's moved 5 squares to the right. That's what that minus 5 does. Right, so we've talked about a scale change, a number up the front which affects the scale or the width, narrow or wider. We talked about whether we can have a vertical shift as well or a horizontal shift altogether. So this becomes our general parabolic formula that will be quite used in a lot of application. Thanks heaps for watching.